enumerations, right? Enumerations we saw yesterday, like our first complex data type we created, and we saw in our enums we could have properties. We haven't seen properties explicitly, but we could have properties, meaning variables, inside of our enum type. We could also have methods, which we saw in our enum type. I'm sorry? Yeah. Is that cool? All right. So we saw enums yesterday. We were able to create a function in our enum yesterday. We created a train info function, and we said functions inside of enums are called methods, right? So today we'll start seeing, or we'll see a different type of structure called structure, or a different type of object called structure, right? Struct for short. Also general purpose, also complex like what we saw with enums, but more flexible than enums, right? Structs enable us to actually create real-life objects as interpreted in programming languages. So I could take a fellow and make an object out of fellow. I would start with a struct. I would put properties, methods, initializers in that particular struct. And that would be the object. That would be an object called fellow. And later I could go ahead and use that object. I create an instance of the object. Before you could use an object, you need to create an instance of it. We saw that yesterday with enums. Before we could use our enum, we have to say, hey, go ahead and create a train. Create an instance of that MTA line, then we could use it. So today we'll see structs. A bit similar to enums with more functionality, right? And tomorrow we'll start seeing classes. So going forward, every object we create in iOS programming will be struct class or enum, right? Based on the purposes of that particular problem you're trying to solve, based on the longevity or how you want to manipulate that object. We'll see the differences between structs and classes, when you should use one over the other, the benefits of them, the pros and cons of them, right? For now, enums, the differentiation there is know that when you're using an enum, you want to say you're creating a type that has cases that's very similar to each other, right? That's what sets enums apart from structs and classes. I want to create a simple type. I want to create a compass. I want to create MTA lines. I want to create blood types. I want to create programming languages. The best use case is an enum for that, right? Days of the week, that wouldn't be ideal in a class or a struct. That would be ideal in an enum type, right? I want to create a fellow. I want to create some sort of object. I want to create a car, an animal, whatever it is. A struct or a class would be better for that. I want to create a game object. A class might be better for that, right? We'll see the differences as we get deeper into each topic. Great. So as it says here from the language guide, it's a building block, right? It enables us to build our program, right? We start out with a simple object. Before you know it, we have multiple objects in our application. You take Instagram. Instagram has many objects going around. There's a friend, right? There's a photo. There's a post. A post has its own objects. A post has comments. All those are encapsulated, right? Encapsulation is also part of our object there. A post has people who liked it. It has likes, right? Comments. There could be pictures or images associated to that. So you see how complex one app could get, right? Based on starting out with a struct or a class, having an enum, right? A weather app could have an enum of types of weather. Cold, right? There's only so many types of weather we have. Everybody with me? Is it snowing? Is it cold? Is it windy? You could put that into an enum, right? You could have associated values on that case of cold. Like how cold is it, right? So that's our introduction to objects and our introduction to what's called object-oriented programming, or OOP for short, right? So object-oriented programming, you start out with an object and you build off that object to build out your app, right? So the majority of what we do in iOS, in the iOS world, for now, it will be object-oriented programming. As we get into protocols, you'll see something called protocol-oriented programming, right? So Apple has those two paradigms. You either do object-oriented programming. You could have both of them, right? But you start one way. Either you start protocol-oriented or you start object-oriented. For the purposes of the majority of our program, we'll be doing object-oriented programming. So you need to think of objects as you're creating an application, right? Cool. So that's an overview of what objects are. Think of objects like a struct, a class, an enum. What object are you relating this real-world life thing to? I want to create a game, right? My game has different objects. There's enemies, right? There's life, there's rewards. All that is objects, right? How do I create that? My enemy has a power level. That's properties on the enemy. The enemy can fire. That could be a method on that enemy there. So we need to start thinking in an object-oriented way when you start thinking of solving a problem, right? You're given a calculator. The calculator has an object. You're given hangman. That could have an object, right? Cool. So here we said structs is a building block of a method in which we emulate an object in programming or in Swift. Because structs could be something else in a different language. Right? But structs in Swift is more robust. You could do more things with structs. Before, structs was more like an enum in Objective-C, but now structs could have functions, properties, or methods, properties, initializers. So that's a basic what a struct is. Let's see what a struct syntax looks like. We start out with the struct keyword. We start out with an uppercase or uppercase, camel case, right? We don't start out with a lowercase here. That doesn't signify to the reader that it's a type. Signifying to the reader it's a type, you start out with an uppercase here. So some struct. And in here is where you build out your definition. So the definition of the struct. Definition could include properties, methods, or put initializers after here. So properties, initializers, methods. Today we'll look at properties, we'll look at methods. Into next week, we'll look at initializers. Or even tomorrow, we'll start looking at initializers. Because we're looking at classes tomorrow. So tomorrow we'll start looking at initializers. But today we look at building out simple structs, putting properties in them. Methods we saw yesterday on enums. But we haven't seen properties yet. Properties are basically variables or constants on the type. In that case, the struct. Methods, as we said yesterday, are functions inside of a custom type. Example, struct here. And initializers, we could say the way in which you create a type, or the method in which you create a type. Includes the following. So with those three properties or those three attributes on a struct or a class, that basically defines an object, right? So everything inside that curly bracket here defines that object, that some struct object, right? So some struct below defines an object. And we could say object-oriented programming or OOP. You'll see on a lot of job descriptions, right? So object-oriented programming here, we could say encapsulates properties and methods on real-world objects, right? What that means, you take a real world object, for example, a fellow, a desk, right? And based on the properties of that particular object, a fellow has an age, right? A fellow has a gender, right? A fellow knows languages. All those, you take those and you encapsulate them, meaning you put them inside of this struct, and you define their properties, their behavior, right? So that encapsulates a real world object into programming. So that's known as object-oriented programming, right? How to encapsulate properties and methods of real world objects. Cool. Any questions so far? So that's the basic syntax. We saw the syntax of enum yesterday. This is the basic syntax of a struct. You start with the keyword struct, the name of the struct. You start out with an uppercase S here, not a lowercase s. Lowercase implies either it's a function, a variable, a constant. Uppercase implies it is a type, whether it be int, string, your own custom type here, which is some struct. Great. Let's go ahead and define the next struct here. We'll call it resolution. Here we'll have properties. Those properties are called stored properties. We'll talk about more properties later. Stored properties. A stored property is a property with a value, a default value. And as we see, a property is a variable. So a property is a variable or constant. And here we have some property called width, which has a default of 0. And then we have height, which has a default of 0. So here we have two properties. So now we're seeing the first use of properties. Here we have our struct called resolution, right? Resolution of some device, some TV, some whatever it is, some device, some screen. We call it resolution. We encapsulate its properties here. We have a width and we have a height, right? Width of the screen, height of the screen. We default it to 0. Right? Now let's create instances of it. Yesterday we created instances. The only way to use this template we have here, this is a template. It cannot be used without having an instance of it. As we saw yesterday, and we saw in our labs, you need to create an instance in order to use resolution. So here we'll create an instance of resolution. Great. So here we'll say let have a constant, some resolution equal to resolution. So here we've created an instance of resolution. It's called some resolution. We could access its properties. So accessing properties of resolution. We access properties how? How do we access properties? With the dot syntax, right? So accessing properties of resolution using dot syntax. So here we could give our resolution a value, right? So we could say some resolution dot width equal to 1080. And here we see that we cannot assign width a value because it's a constant, right? Tomorrow we'll see the differences between classes and structs more evidently, where a class, this would be allowed, but in a struct, you cannot change the value once you declare your struct a constant. We'll come back to that tomorrow. Yes?
So, once you, like, putting resolution after just attaching it to that struct, like, everything that you do.
You mean the constant name here?
Yeah, like, some resolution equals resolution is the resolution, so now it's.
Yeah, now this is a type. So if you option click on some resolution, the type is resolution. So you could access its methods and its properties. Cool? So now I'll change let here to a var. And tomorrow we'll see the differences again with structs and classes when we will show how that is different, right? With a class, it would work because your variables are mutable on a class there, even if it's a constant. We'll come back to that tomorrow. So here we have updated our sum resolution. If we go ahead and print sum resolution to see the object printed. So here we have width of 1080 and the height is still 0, which makes sense. We haven't updated the height yet. Everybody with me? So we've given width a value by assigning it 1080. And we've printed what our sum resolution looks like. So far, so good. Great. Let's create a next instance called VGA. Resolution here. So type in resolution, open parens. That's a little bug here. And now we see we have the third option here. We have width and we have height. Right? Let's talk about that a little bit and what that's about. So here on structs, one of the big differences between a struct and a class, it has what's known as a member-wise initializer, right? So our struct here has what's known as a member-wise. So structs have a member-wise initializer as opposed to a class that does not, right? So here we have a member-wise initializer on our resolution. As we see tomorrow, on a class, we have to create our own initializers if we want to have some initializer with the width and the height option. But on a struct, any properties, all the properties you have, you'll get a default member-wise initializer for it. So here we have width, it says width as a property, and it says height as a property. If you added a third property, it would also be part of that member-wise initializer. So now instead of individually going and set my width, my height, I could say go ahead and use this member-wise initializer here and give it values. Right? So now if I print my VGA object, I'll get width is 640 and height is 480. Everybody with me? With the first option, we use the default initializer, no parameters, no arguments, right? And we had to go ahead and set our properties manually. In our second option here, we are using what's known as the member-wise initializer. Here, member-wise initializer. And that's only available on structs, not classes. So at the interview, when they ask you, is member-wise initializer available on classes, you say no. Right? Only on structs that you get that. Great. Let's go into the heart of the differences between, or the initial heart of the differences between structs and classes. Let's talk about structs and enums are value types. Value types. That will be with you for the rest of your iOS career. What is the difference between structs and classes? So here, a struct is a value type. An enum is a value type. An array is a value type. All the types we've seen before are value types. What's a value type, you ask? A value type basically is, let's show us what a value type looks like, and then we'll discuss what a value type is. So here I'll say let HD equal to resolution. I'll use the member-wise initializer here. I'll default it to 1920 by 1080. I'll create a next variable called cinema. I will say cinema gets HD. Bless you. And I'll go on to say cinema dot width equal to 2048. Right. So here on line 44, I created a constant. It's called HD. I set its properties, its width to 1920, its height to 1080. I created a next variable called cinema. Cinema now has HD. Everybody with me? So it has a copy of HD. I go ahead, I tell cinema, update your width to 2048. The question becomes, that question is going to follow you the rest of your career. What is the value of HD's width? Tiffany. Okay, 1920. Yulia, you say 1920. Anybody say 2048? Great. Okay, we have a couple 2048s. We have a question. You say 2048? Okay. So we say 2048, we say 1920, right? That is the fundamental difference, or one of the differences between structs and classes. Here, I started off with my HD. It had its values. Everybody with me? Cinema. Please write those notes down. Head should be, yeah. So cinema gets a copy. So cinema gets a copy of HD. It gets a copy. The minute we see copy here, we know what a copy means. A copy means it's my copy. I could do whatever I want with it. Everybody with me? What's that? Okay, Tiffany's saying it's forks it. You see that, everybody? Nice, nice. Forks it, right? You fork it, that's your copy. You could do whatever you want with it. It doesn't change the original. Rock stars. So here, copy does not change the original. Object. Right? On Tuesday, no, last week, was it Monday? Forgot. When we did pair programming, we had a spreadsheet. Everybody, I shared out the spreadsheet with us. We all had that spreadsheet, correct? What did we say? Make a copy of it. All right? Make a copy of it. Why? Because now it's your own copy. You could do whatever you want with it. You could edit it. Whatever edits do you put in there, do I see the edits? Do I see the edits? Mr. One, do I see the edits? I do not see the edits. That is a struct. If we could take that to the interview anywhere we go to say what a struct is, we go, right? Tomorrow we'll talk about classes and references there, but for now, if we just understand that, that's a copy. So Mr. Cinema here got a copy of HD. He could change the width. It's up to him. He could do whatever he wants with the width. But Mr. HD stays the same. We agree. Leah? Explain to me what, I'm sorry? Not because it's a constant. I could make it a variable. Right? Not because it's a constant. Mr. Sering, explain to us, why is cinema width different from HD's width?
That's cinema's personal changes, not changing HD's width.
Because it's a copy, correct? I went to the Xerox machine, or the Xerox. I went to the copy machine. I made a copy of my resume. I kept my copy for myself. I handed all you guys a copy. I told you go ahead and edit it based on what you want to do. Do I see your edit? No, I have my copy. You cannot mess with the original. The original is mine. You have a copy, you could do whatever you want with yours. You make a next copy, you pass it to somebody else, they could do whatever they want with theirs. So value types are copies, right? You do not change the original. In a function, when we pass a variable, it doesn't change our value. In the function itself, it's a copy of what we have. That's why we have to return a value. You see what I'm saying? Later on functions, we'll see in, out, and we'll talk about references. Right? That's why I'm trying to go incremental here with you. Because to show everything at once is going to be a bit confusing. So in, out, we'll see when we understand what references are.
Just over here, what's the name of this example?
I'm sorry?
So this example, what do you get the copy?
We started out with HD.
Yeah, these are construct.
They're both structs, right? Because what type is resolution? But at the end of the day, we created that custom type using a what? Using a what? What did we use? How did we declare resolution? What is resolution? Right? So at the end of the day, resolution is a struct, right? It is a value type. Those are instances of resolution, right? They're still structs, they're still value types. You have an array is a value type, right? You say array 1, you say array 2 equals to array 1, you do something with array 2 stays by itself.
Yeah, so we created a different variable.
So we created a different variable, we called it, let's go down, we called it cinema. Cinema got a copy. At this point, before we said width, right? What is the value? What is the value of cinema's width here? Everybody sees that, right? We agreed it's 1920, correct? Right? Because at that point, it hasn't changed its width yet. So far, so good? So let's go ahead and print that. So we print cinema.width. So run the playground right below your print statement. You get 1920. Let me take that a little bit out here. So you get 1920 here. Right? What's HD's width on line 50? HD. 1920. Well, at this point, cinema has changed its value to 2048. So what is the value of HD here? Christian, what's the value of HD here? 1920. Right, so here we print hd.width. We run it, and we get 1920. Exactly. You say that to the interviewer, you go to round 2. Good. If it's a structure, because an array, let's go to the documentation. So now we could understand documentation better and better as we go. So I'll go into array, Swift. I'll look at the documentation from Apple here. Right? And Apple tells us this is a structure. Right? So here, an array is a struct. It's a value type. You with me? An int is a value type. All the types we've dealt with so far are value types. Okay? So an array here is a value type. A string is a value type. Right? So those are copies. They're passed by copy. Everybody with me? Yes? Greg and then Brandon.
So what would be the advantage of setting up, or rather changing just the width for cinema here as opposed to setting up a variable for cinema which inherits the
Inherits. So we'll talk about inheritance tomorrow, right? But for now, you could, that could be ideal, right? I want a copy, and then maybe I don't want all the values of that particular, the original copy.
As we advance, it gets a little more complicated.
Exactly. Exactly, exactly. So it's up to what cinema wants to do. Maybe they want to, like the iPhone devices, right? It took a copy, like when you went from iPhone 4S to 5, the width stayed the same, correct? But the height changed. You see what I'm saying? All right. Cool. So this is good. This is good. Not confused yet. Okay. Tomorrow, I'm still holding my breath there. With what we did today with the previewing of the lesson, please do it tomorrow again. Sorry. Go ahead. If you copy a copy, that last copy has its own copy. It doesn't change the original value, no matter how many copies goes down the round. The copy, for example, cinema with 2048. Some other variable comes cinema 1, copies cinema. It has 2048. In that copy 1 has 2058. Right? It doesn't change cinema. Copy 5 comes in, it's like resolution 5000. It doesn't change cinema. You see what I'm saying? Don't matter which one. So before cinema was HD.
If you copy HD
Uh-huh.
to something else, HD will still stay.
Yes, yes. Because again, it's always passed by copy. Cool? So no matter how many copies you have there. Right? Like I could copy my resume, give it to you. You give it to your brother who copies it, give it to his coworker. At the end of the day, your copy is still the same. Cool? So that's like the benefit, that's the huge benefit of structs there. Your code doesn't change if somebody else copies what you have. Cool? Yes? What is it for? It depends on the logic you're writing for your application. It could be a fellow has a copy from a person, like a person has attributes, a name, an age, whatever, but the fellow has more attributes than the person, right? The fellow has programming languages that they know. You see what I'm saying? So you could make the copy your own in that aspect. Like you copy some object and you add your own attributes onto it. Does that make sense? You expand it. Cool? Like again, Apple might not be the best in innovating, not innovating. Yeah, I want to say innovating. I'll go that far. But they're the best when it comes to marketing and revolutionizing that device. Does that make sense? Like the smartphone wasn't by Apple the first time, right? Like BlackBerry, all those people came, right? They took a copy of what it was and they made it better, right? We all have iPhones. We love them. But the concept itself was there before. So they copied it and they made it better, right? That sounds like BASF. We don't make things, we make them better. Right? Everybody with me? We had Motorola, we had Trios, we had all those things, right? And then Steve Jobs came, it's like keyboard, yuck, stylus, bleh. We have fingers, right? If you haven't seen that, please see it. We iOS developers right now. One of the best keynotes. When the iPhone unveiled. Guys, when you get a chance, please do this. Go to Google. and do iPhone, original iPhone demo, something like that. Right? Please. When you get a break, please, at some point, look at this. Right? So he comes on stage.
And here it is. But what's wrong with their user interface?
Right? So that's the part where he says
Problem with
keyboards,
them
yuck.
is really sort of in the bottom 40 there.
Right? So we had the Motorola, we
It's
had the
this stuff
BlackBerry,
right
the
here.
Palm Trio, Nokia.
They
What's
all
Nokia
have
now,
these
right?
keyboards that
All
are
those
there
companies are
whether you
gone,
need them or
right?
not to be there. And they all have these control buttons.
So again,
that are
they
fixed in
existed.
plastic.
They took the
And
copy,
they're the same for
the
every
best parts of
application.
it,
Every
they made it
application
their
wants a
own.
slightly
And now we have
different
the
user
iPhone.
interface, a slightly optimized.
Right? And he
We
goes
saw-
on to talk about
How
how
are
the
we going to
iPhone, that's the
communicate this?
original
We don't want
iPhone.
to carry around a mouse, right? So what are we going to do?
Right? There's
Oh,
no
a stylus, right? We're
He's
gonna
like
use a
stylus. Yuck. Why we need a
Yeah.
stylus? We don't need a stylus.
Who
Right?
wants
Who
a
wants a
stylus?
stylus?
You have to get them and put them away, and you lose them. Yuck.
Right?
Nobody wants a stylus. So let's not use a stylus.
What are we going to use?
We're going to use the best pointing device in the world. We're going to use a
Use our
pointing device that
fingers.
we're all born with. We're born with 10 of them. We're going to use our fingers.
All right?
We're going to touch this with our fingers. And we have invented a new technology called multi-touch, which is phenomenal.
All right? The guy was
It
awesome.
works like
So
magic.
we look at that in our
You
offline,
don't
we
need a
look at it.
stylus. It's far more accurate than
Yeah. Cool. So that takes us back to value types, right? Please, 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 I'll slack it out, but look at it. Watch it. It's awesome. All right, so we're good with value types now. We know what they are. They're copies. We pass them around, we copy them. We don't change the original, right? So we took the trio, all that stuff, copied it, made it the best phone ever. Still the best phone ever. Minus the 3 cameras looking at you. Cool? All right, great, great, great. Any questions? All right, let us go into some more complex uses of everything we've learned so far. We'll do it in an object-oriented way. So we'll use object-oriented programming. To model a fellow. Okay. Awesome. So a fellow comes to pursuit. A fellow knows many programming languages, right? Coming in, you might not know any. Coming out, you'll know a lot. Going into your job, you'll know even more. So we'll start out with an enum called programming languages or programming language. So we saw enums yesterday. We know enums group similar values or related values together. So we'll start out with an enum, call it programming language. And we'll have a case called Swift. We'll have a case called Java. We'll have a case called JavaScript. We'll have a case called Python. We'll have a case called no language for now. Oh, look at that. How can we forget our love? The first one. So let's talk about programming convention style again. So the type starts with an uppercase. Type starts with an uppercase. In an enum, the cases are lowercase. If you look at all Objective-C code, you will see uppercase here. But in Swift, you have lower cases for the enums, for the cases. Cool? Good. And that doesn't mean it's not going to work. That just means somebody else is going to start seeing you differently, right? There's a lot of anal people out there reading code. The slightest things will turn them off. So when we submit our code to, especially in the interviewing process, we want to be tight with what we do. So we're looking at some style guide or whatever. We have a style guide on curriculum, which is the Ray Wonderlick style guide. Google has a style guide. I think LinkedIn has a style guide too. So those are the things we have to start looking at. For Swift. I think Google has one. Yeah, Google has one for Swift. Why are you confused? Google is a big company. They write iOS apps. They have their own guide. Yeah, right? I think Airbnb has one too, right? So the small companies have their own guides still internally, right? Like some companies will be like, whatever, the $0, we don't use that, right? What does that mean, right? So again, every company is different. Cool, so here we have a programming language. We have some cases in it. And we're creating a fellow, right? Like somebody told us, hey, go create a fellow app, right? I have a fellow app that I created. I create every time I have a new class. How do I start? What's a fellow? What does a fellow have? So that's why you have to start thinking about objects, like in an object-oriented way. What does a fellow have, right? A fellow has a GitHub URL, right? A fellow has a LinkedIn, Twitter, right? Instagram, hopefully employers are not really looking for that there, unless you go into, I don't know, who knows. But that's what a fellow has, right? A fellow has a portfolio of projects. So let's model a fellow using object-oriented programming. We started out with programming language. A fellow is going to know programming languages. Maybe they have an array of programming languages, whatever. So let's go model that fellow. We'll start with a struct. Apple always says start with a struct. Every video you see when they come out with like talking about Swift in WWDC videos, start out with a struct. It's like saying start out with a let. Start out with a let. If you want to change, go back to a var, but start out with a let. Make it immutable, right? A struct also immutable by default. Let immutable, right? So here we start out with a struct. We call it fellow. All right? We said objects have properties. We said objects have methods. Right? Think of the methods like actions, right? Actions that fellow could do, or actions we could do on that fellow. So think of the methods as actions, right? And the properties as attributes. What does a fellow have? Fellow has an age, cohort, whatever. So here we have properties. The fellow has a name, hopefully. Right? So here we have fellow, name. I'll have a default, John Appleseed. And here, what did we say? What type of property is this? We said this is a stored property. We'll talk more about properties. But don't feel free to read properties. It's in the language guide. Read ahead. So here we have a property, it's stored property, because we have a default here. It has a property in there. It has a value already. It has a value, it's called a stored property. So here we have a name. We have cohort. If I say 0.0, what data type is that? It's a double, great. So here we have programming language. Languages, plural, implies many. Why do we say plural? Because it's an array. It's an array of programming language. Right? You see how everything we're learning so far, we're bringing it together here? So here we created our custom type called programming language. It's an enum. And now we're giving our fellow, which is a custom type, it's a struct. We're giving that fellow an array of programming languages that they know. And already we see it's one of those cases, right? That's only the valid cases. If I said make the programming languages a string, then you could put in anything there. Everybody with me? Right? So here I have an enum. I have the cases of languages. My fellow has name, cohort, and the programming languages they know. Great. What else does the fellow have? So we say the fellow might have a GitHub URL. For now, I'll say it's a string. Yes?
When you made a variable programming languages, why did you have the array and then a constructor right after it?
Just because it's empty. Yeah, good question. Why you felt like you were asking a right question? It's a good question. So here, programming languages is empty, right, as Mr. Ahad pointed out. Because we have the initializer syntax at the end. It implies we created it. There's no objects in there. Currently, it's 0. Everybody with me? We could also default with a language if we wanted, but for now, it's empty. So great, we have a GitHub URL. We could say we have LinkedIn. LinkedIn URL. We could have a Boolean here saying has programming background. Set that to false by default. Right? The projects they have. Right? And here we'll create a custom type for projects. Right? So right above fellow, I'll create a struct called project. Right? What does a project have? Anybody? What should a project have? A what? Yeah, project name, right? What type is project name? A string. What else does a project have? We've created 3 projects. What else does a project have? How do you know one project from the other? Somebody else. Anna, how do we know one project from the other? Description. Very good. So a project has a description. So project has a description. Okay, we have web, we have iOS, Android. What else does a project have? What's the differences? When somebody reading the code, what is that? Language. Thank you, sir. Project is written in some language. Call it programming language. So what type is programming language here? Who said that? What type should programming language be? Is it a string, a bool? A string. Anybody else? String is good. Programming language, right? Because we have programming language here. We created programming language. So instead of making it a string, whether the user could put any string, right? We protected against having only one of our cases. So we say programming language. You cannot put in your own type. If you say string, the person could come in and say, my language, you know, some language, zombie language, any language they want. But here, our program has been protected because whoever is creating a project, it has to be a valid programming language that we created. So here, I could say programming language. I could even give it a default of Swift if I want. It's up to me. Or no language. Right? Cool. So we'll stop there for project. So you see how we could encapsulate real-life objects, right? What does that object have? How do we want to emulate it? What does a car have? It has wheels. It has a color. Right? Hopefully it has an engine. Right? All those things. We could take them, break them apart, and what do we want to have in our object? So for our our project next week, we have to think of the objects we have. It's going to be a 2-day object-oriented based project we have to build? 2 days. If you finish in 1 day, then the second day is pitch day. Right? So here we have objects, like, hey, I want to create some, whatever it is. I want to create a TV show. What does a TV show have? Actors, right? In the actors, you need to get an object for actor. And your TV show will have an array of actors. You see where I'm going with that? Right? That's how we do it. When you have the Spotify app, right? What does Spotify app has? Yes, there's music, there's songs, there's all that, right? But what does an album have? Album has artists. The artists themselves have albums. All right? You see where we're going with that, right? So at the end of the day, it becomes really complex. But the earlier you think about the objects you want to create in your app, the better. Because you don't want to get to a point where, ooh, how does actors get albums? Because you're in a point where you want to get the albums for the actors. Like, how do I get there, right? If you break it apart, break it apart, make it nice and small, right? Next week, we'll start seeing, or maybe tomorrow, where we break apart files in our command line application. Yes, sir?
How did you assign programming language to some name?
We could name this different if it's weird. Call it language.
But how did it work in the first place?
It's going to work because this is not taken. This is just a variable name.
Is this by itself or is it within?
Which one? This one?
No, is the struct in its own block or is it?
Yeah. The struct is in its own block. I'm a little, 1 second. So where are we? Did we name this? You mean here?
No, right where we were.
So line 73,
Yeah,
we named the variable language or programming language we had earlier, right? And then we assigned it. We assigned it the type. That's a type.
how come it doesn't give you like an error saying you can assign it itself?
Oh, that's not itself. That's assigning a variable some type. Right? So this is what we're doing. So basically, this is what I have. I have var string like that, for example. And I could say string, right? That's like very similar to what we have, right? So even if I call it string, that doesn't mean I can't assign a string to it. Right? Does that make sense? Cool. So here you could call it language you want. That's fine. To make it easier. Okay, so we're talking about types. Make the type small, make it useful. Tomorrow or Monday, we'll look at breaking up file names where you have a file name called project in our command line application. So we'll break those up into files. Yes, you have a question? One second. In fellow? Is it in fellow? Which object? In fellow? This is fellow object. We're not done yet with that. Yeah, because we realized, oh, we need a new object. Let's go create one. Cool. That's how we have to start thinking. Okay, cool. So any questions about project, Mr. One? We good? Okay, so we have a project object. We have programming language object. One is an enum. And we have two structs. Great. So now let's go back to line 84. A fellow has projects. What should project be? Projects be. What should projects be? What data type? Array. Array of what? Array of project. Boom. Right? We created project. Look at that. Forget a string. String doesn't help us too much. Right? So now we have an array of projects. Very nice. Our fellow is getting cool attributes here. Yes, sir.
We can use a struct as like a data type then?
Yeah. It's an object. We should use it as a type, data type. It is a data type. And an enum is also a data type. We have our enum here, programming language. Very good. Okay, cool. Let's see what a method looks like. So here we have properties and we have methods. So when you organize in your code, try to start with the properties first, followed by initializers. We're not going to have initializers today. So if you have any initializers here, and then followed by methods, and then methods could, actually let me not go there. When we talk about methods more, we'll talk about that. Yeah, let me just write it, whatever. So we have class methods first, that's the way you should organize your code. And then we have instance methods. And the very first one, we said we have properties, right? Let me go back to that and just fix the headline there. Boom. Properties. And remember, properties could be variables and constants. So yes, we have var there, but that could easily be let. We'll see that later. Cool. Initializers, methods, great. So let's create an instance method. Call it function info. And an instance method gets its name because it only works on an instance. We know what an instance is. We create an instance from the type. We say var some instance equal to type. So instance method only works on the instance. As we saw yesterday in our enum. We said enum instance.info. And class methods work on the class itself. All right. So let's do an instance method here. So when I say info, I want to print the name of the fellow. Currently has X amount of projects. So projects is an array. Projects.count. Portfolio projects. Cool. How are we doing with the code? We up to date? Everybody up to date? Almost. Where should I stay here? Here? At the info? Okay. Cool? Okay. So moving on. Let's go down. So now we're outside of our struct. Make sure that you're outside the struct. Our struct is fellow. That's the last struct we created. So make sure you're outside of all those brackets here. And we're going down, and we're saying creating instances of objects cool. So first we'll create an instance using the default initializer of fellow like this. We'll start out by saying var Greg equal to fellow like that. We'll give the fellow a name. We'll give the fellow a cohort. we'll give the fellow projects or project. So our array is projects, right? How do we add to an array? How do we add to an array? Oscar? Append, right? So here we say dot append. So we add in a project, right? So we have our project struct, our custom type. Everybody agreed? So here I will say project, right? Open parens on project and select the member-wise initializer. Right, so project, open parens, select the member-wise initializer at the bottom. Do we see that? Yes? The one that has all the options for the parameters. And go ahead and press enter. And let's start filling it out. So project name here, I'll say Hangman. Tab over. So when you finish when you finish typing in Hangman, just tab over to the next one. It says project description. All right, so Hangman, command line, macOS application. When you finish with that, you tab over to the language. And here you could use dot syntax because it knows what to expect. And I say Swift. Great. So far, so good? So we saw a great use case for enums on day 2. This is excellent use case. Instead of saying language and putting like Swift here, like this, our enum is more powerful because now we know it has to be one of those cases. We don't have to go check, like, is it lowercase, uppercase? Right? Did they put Swift like this? Right? It's type safe. That enum now makes our project type safe. Everybody with me? Powerful use case of enums. Amini, does that help you a little bit from yesterday's question? So when we do more demos, we understand more context. Does that make sense? So now we have Swift here. So Greg has a project. The name of the project is Hangman. The description is Hangman command line OS application. Right? Great. So now we could use the info method we created, right? The info method we created here, function info, is an instance method. Keyword, instance. Everybody with me? The only way I could access info is through the instance, and the instance is Greg. Are you with me? So now I could simply say Greg .info. Let's go ahead and print Greg's info. So now we see Greg currently has one portfolio project. Do we see that? What would be what? Which one? Should we go back to the function? Okay, so we have info, right? Which is an instance method. It could only work, I could only call it, can only be called using instance name.info like this, or example greg.info like that. That's the only way I could access that method of the fellow struct, yes. It overrode it, right? No. Greg? Print Greg's name. Yeah, but if you print out Greg's name, what's his name now? Well, we printed out Greg's name, sorry. It's Greg. That's a default. John Appleseed is a default name. I know. So when you printed it at the end, it should be Greg, correct?
This is the same thing as if we did fellow.info.
You cannot do fellow.info. That's a compiler error. Let's go down. So if we say fellow .info, like that, first of all, it doesn't appear. That's already giving us a warning, right? So if I say fellow.info like this, that's a compiler error, right? Instance member, it tells you, instance member info cannot be used on fellow, right? Did you mean to use value of this type instead? Mr. Christian, that's not gonna work by saying the type dot method name.
Yeah, I'm sure that you work with the HD and cinema stuff.
The HDN cinema stuff was showing what value types are, right? Pass by copy.
Say this is when we did var grad equals
This is creating an instance. We wrote it there, right? Yeah. So this is creating an instance. Greg is an instance of fellow. Earlier, when we showed the HD part here, right? HG is an instance of resolution. So any other questions there? You have a question?
I was trying to compare it like between like grad and John Harris to this.
I see your question. So your question is the value type question. But in that case, Greg here is not, that name is a property. Yes. I'm not copying Greg and saying, if I have a next name here, like Christian, copying Greg, right? Then Christian gets his own copy, right? And then he would have Greg's name, which would be weird. And then he would change name to Christian. Does that make sense?
Yeah, yeah, yeah.
Okay. No, good. So this does not compile. I'll leave that here. Does not compile. Does not compile. Not a class method. A class method is called by using the class name. I'll do a very simple example. Did we take the note yet? Can I go up? Can I go up? Okay, so we've seen instance methods, right? We know what an instance method is. Mr. Jahid, explain to me what's an instance method. So an instance method, yes, you create a function, it's a method, but the instance method could only work on an instance of that type. Yeah, exactly, of that type, right? So that's an instance method. A class method works on the class itself. Actually, I'm not going to show class methods today. Let's absorb that first. Cool. I'm not going to show class method today. Can only get called from an instance. Yeah, very similar to Greg here. Greg is an instance. We're able to say greg.info. So the instance method only gets invoked or can be called from an instance, not the class name itself. Because I can't say fellow.info. That's not going to work. I have to create an instance of it. Cool. All right, let's create a next fellow here. We'll create Oscar, fellow. So before we use the default initializer, no variables, no parameters, now we'll go ahead and use the member-wise initializer, right? So scroll down to where it says name, cohort, press enter. And here we have our member-wise initializer. All the variables and constants we have in that type, now we need to go ahead and fill them out. So we'll start out with the name, Oscar. Member-wise basically takes all the variables in that struct and it gives you access to it for you to create an object from that. So we didn't have to go step by step here like name, cohort, projects, individually. It gives you access to all the properties. To create. On creation, you have access to all the properties. So double here, not double, sorry, I mean, yeah. So here we have 6.3, programming languages. What do we have here for this? Swift, right? So for programming languages, what we did, it's an array. Everybody, it expects an array. Are you with me? For programming, type in fellow, open parens, and the option with the variables.
Oh, so that's why. But you can't just put dot Swift. That's only on the original.
Okay, we created Oscar, right, Sarah? We said Oscar is a fellow. We open parens. We scroll down to the option with all the parameter names.
Oh, I see it now.
Yeah, no worries. And then we press enter and we said the fellow name is Oscar. We said his cohort, 6.3. We said programming languages, which is an array. Everybody? So I do my array syntax, open square bracket, close square bracket. Inside my programming languages, it knows the type already. Everybody with me? Swift is a really good language. It knows that type. So I could simply say dot and add one of the languages. Right? Again, the enum here is way more powerful than having some string. Say that again. Well, GitHub URL is just a string. Yeah, it has to be in quotes for the string. It's a string.
Okay, when I was in Italy for class, I thought that they just inferred that it was a string, so no matter what I put,
Oh, I got you. You have to put the quotes. Yeah. All right, so here we have Swift. Tab over for GitHub URL. You could put HTTP s github.com. That's fine. For LinkedIn, https://linkedin.com. And has programming background. Mr. Oscar, do you have a programming background? False. Projects. What do we have for projects? We'll just keep projects empty. So just make projects here and put the initializer syntax at the end of projects. So it's empty. It starts out being empty. So that's Oscar. We've created Oscar. We've created an instance of Oscar. So we've created an instance of fellow called Oscar and used the member-wise initializer. What's that? Which one? Oh, for this one? You have to give it some value, right? Like I cannot just leave it empty like that. I mean, that would be an error, right? You expect something. You with me? Okay. We haven't seen optionals, but if it was optional, you could have done this. But your types could also be optional.
So can you put in just like in parentheses?
It's expecting some sort of double for the cohort. So I could put, yeah, you could do that, which defaults to 0. Which defaults to 0 anyway. Yeah. But ideally, what should be, that's why you refactor. Actually, you guys are going to refactor. Refactor our cohort. Refactor, where do we have cohort here? Refactor cohort from a double to an enum. I like it. Blame it on Kelby. Because you guys want to put anything there, right? You want to put double, open, you want to do stuff, right? So refactor this to be some sort of enum. right? Where I say like cohort dot, give it a default like iOS, for example. So I want that code to work. Like the way I put it now, I want that code to work. So create some enum called cohort and give it cases where iOS is one of those cases. Just make it 6.0. Actually, sorry, just make it iOS. Just keep it simple. So cohort is going to be iOS, web, Android. Cool? No, it doesn't. So our cohort should have iOS, Android, web, and in the future, data science. So either you belong to iOS cohort, Android, web, data science. Cool? How are we doing? You getting there? You finished, Chelsea? Come create it for us then. Create it right here on line 76. Give it up for Chelsea. So Chelsea is creating an enum called cohort with 4 cases.
What's the second one? Oh.
Cool, thank you so much. So perfect, you see our code works already, right? So we have cohort.ios for the default for Othello, and we have some more refactoring to do. We go down and we have to update this, because now this doesn't not work. So I will simply say fellow is cohort, should work with dot syntax, by the way. It expects some sort of cohort here. And over with Oscar, right where we have cohort here, just put .ios. Great. Our code works. It's good. So you see, you could refactor as you go. Like we realized double doesn't really work there. We could have our custom type, right? So we went back and we said create a custom type for cohort, right? We created a custom type. Feel free to do that as needed. Your code becomes more type safe, right? There's no accidental adding things like 6.7 or some cohort that doesn't exist. You see what I'm saying? When you have an enum, it's exactly the values, those options you have. In our case, we have 4 options. If they use it as anything else, we go to default, unavailable. Does that make sense? Very good. So keep your code tight and defensive. Great. So that's good. Projects, good. So let's go to all the way down. Let's go to Oscar. This is Oscar here. And let's go ahead and print Oscar's info. We have Oscar's info by simply saying, Oscar, get me your info, .info. And we see Oscar currently has 0 portfolio projects. What's happening, Oscar? Right? So it's 0 because we initialized it to an empty project. We could give Oscar a project like we did before. Right? Actually, you guys go ahead and give Oscar a project. So assign or add a project to So add a project to Oscar's portfolio. Cool? we gave Greg a project this way here. We could give Oscar a project as well. So if you want some reference, look at what we did with Greg. We said Greg projects, append some project. So give Oscar a project. So next time we print out info again, it should have at least one project. You could add more than one. Or you could create projects somewhere, just drop on them. It's going to be yeah, I got it. We have three, our project has three properties, right? We have the main description and language. Oh, yeah. The best way, well, maybe create projects outside and then grab one of those into Oscar. Like append it, you know what I mean? Like create a Hangman project by itself. You see what I'm saying? So if you want to create multiple projects, the easiest way is to create them outside somewhere, like Hangman, create a project, create calculator project, and then you could just add them to Oscar. Does that make sense? Like create instances of projects. Like create 3 instances of projects and then say Oscar.append projects. That would be nice. Next challenge. Very good.
When you say make projects,
No, make instances, because we have a project struct already. So I'd create like new instances of projects. So people that want to create more instances, I would do something like this. I would say let calculator app, for example, calculator app, like that. And I would say project, and go ahead and create a project using the member-wise initializer. And I would say project name is calculator. I would say description is calculator command line application. And the language, I would say Swift. So here we have an instance of a project. So far, so then. And for Oscar, I could simply say Oscar dot projects dot append calculator, like that. And now if I say Oscar dot info, how many projects will Oscar have now? 2. Wow. No, 1, right? Because he had 0 before, right? We increment by 1. You have 2 for Oscar? Oh yeah, that's fine. Yeah, you could. Oscar could have many projects. He should. He's a developer. He builds. We don't stop on 1. We don't only do what's assigned to us. We do more than that, right? Who's the instructor to tell us what to do? We create apps every day. We sleep, we create apps. So here, this is an instance of, or instances. We could have multiple instances. So instances of projects, right? Oscar is going into advanced stuff. He's doing an Instagram clone. So Instagram clone, right? is the next project that Oscar created. Using member-wise initializer, we go ahead and we call the name Instagram, clone, description, best social app. Programming language. Look at Oscar. He's doing it in Java. Right?
Isn't that an instance of projects?
Of project, yes. Thank you. Love it. So this is an instance of project. And here we add more to Oscar. Oscar gets a new project. So projects dot append, and we appended Instagram clone. Right? So now Oscar is a rock star. He has 2 projects now. Cool? Right? So today we're really using all what we know to create object-oriented programming applications. And we'll see later how we could break those files up into their respective components. Let's create one more instance before we wrap up today. One more instance method. How we do it? We okay? Can I scroll up? No? Just wait here, right? Instances of projects. This is good. Add a project to Oscar's portfolio, or add projects to Oscar's portfolio. We added 2. Now Oscar has 2 here. Yeah, enums are beautiful, like really beautiful. Like this here, this is beautiful code, right? I'm not saying some string Java. I'm just saying get me one of the cases. Boom, done. When we did Oscar, yes. Yes, so currently in our project, we have 2 instances of fellows. We have Oscar and we have Greg. And it's very easy to create more programming languages. We just have to add to our enum, right? Add a different case, add a next case. Right? So maybe Oscar just wants to do Android here. Do we have Android? No, we don't. So we could just add, well, Android is not a programming language. Or maybe Kotlin. Can I scroll up? Kotlin. That's, instead of using Java, you could use Kotlin, which is like a newer language, more Swifty, to write Android apps. Right? So, always new things to learn. How are we doing? Can we scroll up? Yes. Errors.
It said that I was using the variable in its own variable.
Oh, which one? What line?
For the calculator app.
For calculator app here. So you started off, you said let calculator app equal to project. You use the member-wise initializer. Project name is calculator, it's a string. You said project description, you give it a string. And you said language is Swift. Maybe it's above it, the error. You got it? You solved it? Okay, cool. Good? All right, perfect. All right, so let's go up and create one more instance method for the fellow. And again, class methods, will come to that later. Just not going to show too much to derail us. I don't want to derail us. Keep us on track. We're doing good. So here we have a function. It's called resume. Because we haven't seen a function taking in a parameter on an instance type here. So we have resume. It takes in some parameter language, which is of what type? What type should it be? A string? What type is this? Programming language. Very good. That's our own custom type we created. So here we have resume. It takes in a language. I'm right below function info inside of the struct, the fellow struct. So make sure you're inside your fellow struct, right below our function info. Cool? And we created a new instance method. We call it resume. Takes in a language, programming language. And it says if self, we love self, if that instance programming language what do we have? Oh, I don't have a programming language, do I? What do we have? Programming languages, sorry. So if the instance programming languages that contains the language that got passed in, great. Then this particular fellow is in business, right? So name, a mini, maybe more sophisticated algorithms. So here we have name can, right below function info. Right below function info, we created a new function called resume. Tiffany?
Yes, which is still inside,
The struct, inside fellow struct.
inside of.
Yeah. So here we have name can be hired for this language position. Great. It's awesome. Else print if self. If self. So if that instance programming language contains the language we're interested in, self is the instance. Example, Oscar is an instance and Greg, correct? So replace self with Greg. So if Greg programming languages contains that language, cool? So that's what we said with self yesterday. Self represents that instance that called the resume function. Cool? Very good. So here we have name is not okay. So self, as I said, represents the instance of fellow that called resume. Example, Greg dot resume language dot Swift, for example. So when Greg calls resume, self gets replaced with Greg. Everybody? Everybody? Cool. So our instance method is ready for testing.
Oh.
Cool? Good? Okay, so let's test it. Actually, I need to go down to test it. So are we done typing? No, okay. Make sure you say in self.programming languages, right? That contains parents, the language. Language, you're talking about this language? That's the one, the caller of the function passed in. Yeah, the enum, one of the enums. One of the cases of the enums. The array I made, the variable is called programming languages. That's the variable we made. A fellow has programming languages, remember? If you look at your fellow, yeah, the array of, yeah, exactly. But a language is a single, a single type, a single case of the enum. It could be Swift, it could be Java, it's not everything at once. It's one of those languages. So remember, when we call in Greg like this. We call in Greg like this. We're passing Greg one of the languages. .Swift, or .Java, or .Ruby, whatever it is. Cool? Good? All right, cool. So let us test it. Can we scroll down? Okay, so let's scroll down all the way to Oscar here and use our resume. So Oscar.resume. Does Oscar know JavaScript? And run it. Let's see what Oscar is happening there. Okay, Oscar is not qualified for this position, right? Oscar applied, he doesn't know JavaScript, but that's fine. Let's see if Oscar could apply to someplace else. So Oscar.resume.Swift, run it again. Hey, Oscar can be hired for this Swift position, great, right? So Oscar tried JavaScript, didn't quite get it, but Swift, he got it, right? So Oscar is all smiles right now. Very good. Oscar is smiling. It's a good day. It's a good day. Excellent. Cool. All right, so today we saw structs. We were able to create more complex objects using structs and enums today. We were able to create a fellow. We were able to create programming languages. Let's scroll all the way up and review what we did. Whoa, we did a lot of stuff. So we started off talking about the syntax of a struct. We started with a struct. We give it a name. Make sure it's uppercase. I will see lowercase when we're doing code review. We will give you feedback until when you get it, because you submit that to the employer. Some people are really anal, so be careful there. So structs, we start our name with an uppercase. This is great. We have our definition inside our curly bracket. We defined a struct called resolution. We had two properties on it. We said a property could be a variable or a constant. Here we have two variables, two properties, width and height. They're both integers. We went out, we created an instance of resolution, our custom type that we created. We call it some resolution. We gave it a width of 1080. We printed it. We created a new instance from our resolution called VGA, printed VGA. We went on to show what structs are, and structs are value types, same as enums, they're also value types, same as in strings, arrays, all are value types. We said what value types is. It's a copy. It's passed by copy, right? So the original stays the same, and the copy is up to the copy to change its own contents. It doesn't change the original. So we created HD instance here from resolution. Cinema got a copy of HD. Cinema changed its width to 2048. That did not change HD's width, because remember, it's value type. With a class we'll see tomorrow, this is different. It will change it because they're all pointing to the same reference. So please read on classes because it's a bit more it's different, right? Very good. We went into object-oriented programming. We spoke about modeling real-life objects using object-oriented programming. We said object-oriented programming encapsulates properties, methods into a custom type, right? So we started out by modeling a fellow. We brainstormed what a fellow should have, right? So we said a fellow has a name. A fellow has a cohort. We created an enum for the cohort, right? It's more type safe to have an enum here as opposed to using a string. We saw why. It's very simple to create a cohort here. We simply say .ios. As opposed to having some string value, we have to figure out, is the Swift entered, is that the Swift we want, right? So we encapsulated all the properties of that fellow in this object called fellow. Fellow has properties. Fellow has initializers. We do use the initializer on a struct. We said we have a member-wise initializer by default, right? A fellow has methods. We said there's class methods, which we haven't seen yet. And we saw instance methods today and yesterday. We created two instance methods, info and resume. Right? Info tells us the fellow's name and the projects they have. We also had a resume method that takes in a parameter here of type language that we created. We created instances of the objects, of fellow objects. We created a Greg instance, right? Greg had a name, a cohort. We appended a project to Greg. We used the instance method here on Greg, so greg.info called our info method. We went ahead, we created an Oscar instance using the member-wise initializer. This is the member-wise initializer that we get from a struct by default. And we see in classes we don't have that tomorrow, right? And those were the instances of a project. We created multiple objects, multiple projects, and we gave Oscar more projects. So at this point, Oscar had 2 projects. On our resume, we passed in JavaScript to see if Oscar knew JavaScript. He was successful by knowing Swift, right? And he got the job. Very good. Any questions? Very good. So we'll end here.